Very good morning. I am Dr. HimaBindhu, Faculty of Institute of Aeronautical Engineering from the Department of Mechanical Engineering. I'm here to explain you about robotics subject, and today's topic will be end effectors. What is an end effector? What are its applications? What are the types of end effectors? Where they are used and how they are used? All that will be seen in today's content. So, end effectors. What do you mean by end effectors? What basically is meant by end effectors? What is the use of an end effector? Yes, generally a human body has a wrist, right? In order to perform any action, in order to perform any particular work to be done, to pick or place any object from one place to the other, or to eat, or to do any sort of things, we need a wrist. It is a wrist which is being attached to the hand. With the help of the wrist, the works will be done. The movement of the works will be done. Right? In the same way, a robot also requires a wrist to perform its operations. Right? A robot also requires a wrist to perform its operation. So that wrist is called as an end effector. Right? The wrist which acts in the human body, same as alike. A robot also has a wrist which is called as an end effector, which is used to perform various actions which is being done by a manipulator, in various different applications. So, in order to select an end effector, we have various constraints. In order to select an end effector, select a right end effector, we have some various constraints according to which an end effector design and selection will be done. So choosing the right end effector for a particular robotic application can be a bit complex, and vital decisions are being involved in selecting the type of the end effector. Right? Choosing the right end effector for a particular robotic application can be a complex and a vital decision, as it can significantly impact the robotic effectiveness and efficiency. Because when we are not selecting an appropriate or a correct right end effector, the efficiency and effectiveness of the robot will gradually reduce. There will be a decrease in the efficiency and effectiveness when a proper end effector design or proper end effector is not chosen for any particular robot to perform its action. So here, these are the 5 components which are very important to select an end effector. So here are some key factors to be considered when choosing the right end effector for a robotic application. What are those key factors? Let us see first. The first one is end effector capability. What do we mean by capability? End effector capability. What does that mean? What does that actually mean? Right? We all know, as a human being, we have some constraints. We can lift only the objects which are weighing up to 20 or 25 kgs. There is some limitation, right? But here, at the same time, when we take a robot, that also has some constraints. So it should be capable of lifting certain amount of the load, right? The robot's wrist should be capable of lifting certain amount of the load to handle the objects from one place to the other, or to hold the object from one place to the other, or to move the object from one place to the other. We have to design an end effector, or we have to choose an end effector in such a form, such a way that it will be capable of lifting heavier loads which a human cannot do. Right? For example, we have a 100 kg load. right? We have an around 100 kg load. So can this be done by a human body? Can this be done by a human? No. A human cannot carry, or cannot lift a 100 kg load and move it to another part. So this will generally be done by a robot, right? This can generally be done by a robot when the selection of the robots and effector is done correctly. When the selection of robot, design of end effector is done correctly. When the design of the end effector is being chosen correctly, in that particular stage, the robot can lift heavier loads, and it can do some material handling in the industrial applications wherever required. So it should be capable of lifting heavier loads, and it should be capable of withstanding that heavier loads, and this particular type of the robot can be used in industrial application, right? Next, coming to the task requirement. What do we mean by task requirements? Depending upon the type of requirement, right? We have various tasks to be conducted in industries, right? As we all know, we have various tasks to be conducted in the industry. What are the various tasks to be conducted in this industry? For example, we have welding, we have spray painting, or we have some other form of laser treatment, so etc. So all these particular tasks, whatever is to be conducted in the industry, should have some requirement. That is, the end effector should be designed according to the task requirement, right? The design and selection of the end effector should be done as per the task requirements. Like this, for example, when we need to do any sort of welding, that particular type of the end effector should be designed in that particular form. When we need to do some spray painting, then that particular type of the end effector design should be done in that particular constraint. So the task requirement, whatever is there, the design and selection of the end effector should be done based upon the task requirements. Clear? Next, the third one is the compatibility with the robotic system. That is, the robot, whatever we are selecting, it should be compatible to the environment, right? The selection of the robots and effector should be done based upon the compatibility of the robot system. That is, it should be able to work in both the constraints. Like, for example, we have a marine industry. There also the design of the end effector should be done in such a way that it can work in any constraints. It is compatible to work in any constraint, whether it is a marine industry, or whether it is any automobile industry, or whether it is any sort of welding industry. Wherever we are working in that particular form, the end effector should be compatible to work with the robotic system. Next, coming to the maintenance and repair. We have to take care that the end effector's maintenance and repair will be minimal in order to decrease the cost. The design should be done in such a way that there will be no much maintenance and repair constraints to the end effector. It is the selection of the end effector. The design of the end effector should be done in such a way that it will minimize the maintenance and repair, because as we all know, when there is a continuous task being done by the robot, after 1 or 2 weeks, the end effectors, the grippers will be worn out. Right, the end effectors grippers will be worn out, so they will be they are in need for a maintenance and repair. So, in order to reduce this particular, in order to minimize this particular constraints, we need to select, or we need to choose an end effector, or we need to design an end effector to minimize all these particular sort of constraints. Next, coming to the cost effectiveness. As we all know, any particular large scale or small scale industries will majorly think about the cost. So the design and construction of an end effector should be less cost constrained compared to the other. Right? That is, the cost of the end effector's design should be less compared to the other basic forms of the robot. So these are a few of the points which are to be noted down in order to select any particular type of the end effector. It is in order to choose any particular right end effector, these are few of the constraints which we need to keep in mind and design and or select an end effector. It is firstly end effector capability. We need to check its capability as per its load constraint. Next, task requirement. We need to design the end effector as per the task requirement depending upon the type of the application. And next, based upon the compatibility with the robotic system, we will be choosing the end effector. Based upon the maintenance and repair also, the end effector design and construction will be based. And the last one is about the cost effectiveness. So based upon the cost also, the end effector's design will be held. Next, moving on to the applications of the end effector. Where all can we use this end effector? What are the various applications where we can use this particular end effectors? As we all know, the robots are generally used in manufacturing industries, in food and beverage industries, in healthcare sectors, in agriculture, in automobile, in constructions or in entertainment. In these particular various industries, in this particular various forms, we are in this particular various applications, we are using robots. So, these robots, when they are used in different sectors, depending upon the application, the robot end effector system will be changing. Depending upon the type of the applications, the robot's end effector will be changing. The design of end effectors will change. Based on the application. Clear? Based on the application, the design of the end effectors will be changing. For example, we are taking a manufacturing industry. In the manufacturing industry, we are generally manufacturing some, for example, let us take some machine. Some machine has been manufactured. So that particular machine cannot be moved manually by a human because it is with a heavier load and it requires more force to be applied to move that particular machine from one place to the other. So there, we will be using a robot where it will hold that particular machine and place it in the other place wherever required. So there, the design of that end effector will be changing. Whereas when we take food or beverages or when we take any sort of healthcare sectors, there we generally use vacuum type of end effectors, whereas for the manufacturing type, generally we use mechanical gripper type of end effector. Whereas when we come across food, beverages or healthcare or agriculture, in those particular constraints, we generally use vacuum type of the end effector. Right? That is wherever we have a smooth movement to be done. There or wherever we have a block-like containers to be shifted, there generally we use vacuum type of the end effectors. Whereas this particular vacuum type of the end effectors cannot be used in some automobile or any manufacturing industries, because there we cannot suck the particular product with the help of the vacuum and place it at the other place. So there, with the help of the gripper, we need to hold the object and we need to place it wherever required. That is, there we require a mechanical gripper mechanism. The end effector's design is in the form of a gripper where it grips, where it holds the object and moves a particular object from one place to the other. So the mechanical type of the grippers are generally used near manufacturing or automobile or logistics or even we can say in construction. In constructions, we generally use hook type. In constructions, we generally use a hook type of robot end effector, because there we need to shift the slabs. For example, we have a slab. So in order to lift a slab, we cannot generally do it with a gripper, or we can't shift the slab with the help of a vacuum gripper, or we cannot do it with some servo motor gripper. So there we are considering a hook type of end effector, where with the help of the belt, the slab is been shifted from one place to the other, or the pillar is been shifted from one place to the other. That is generally been applicable in the construction application. The hook type of gripper is generally used in the constructional application, whereas the vacuum type of end effectors are generally used near the food and beverage, healthcare, agriculture, etc. Whereas the mechanical type of the gripper are generally used near the manufacturing, automobile industries. Whereas the servo motor type of the end effectors are generally used for the entertainment or logistics, etc. So these are few of the applications where we use the end effectors. Different types of the end effectors are being used at different applications. So, coming to the types of the end effectors which are used in the robots, as I've told you, we have three types. One is the gripper type, the other is the sensor, and the third one is the camera. So, what do we mean by the end effector? End effectors can be broadly classified into three categories based on the design and construction. Right? Based upon the design and construction, the end effectors are being classified into three types. One is the gripper, sensor, and the cameras. So, what do we mean by gripper? As I've told you, it acts like a hand wrist. So, here the grippers are again being classified into four types. One is the mechanical gripper, vacuum type of the gripper, magnetic gripper, and the servo gripper. So again, these particular gripper designs or the selection of the grippers will be based upon the type of the application. These are again being based on the type of application. Right. That is, when you take a mechanical gripper, as I've told you, generally they are used for automobile industries, or in mechanical or industries, like large scale industries where we need to do material handling to be done. There generally we are using a mechanical type of the gripper. It is coming to the vacuum type of the gripper. Let us see the image first. This is the mechanical gripper, right? This is the mechanical gripper, and this is the vacuum type of the gripper. Right. This is the mechanical gripper, the first image which you are seeing, and the second one, this is the vacuum type of the gripper. So here in the mechanical gripper, what is happening is, we have a fixed base. The base is being fixed, and to the base we have a waist being fixed. That is, the robust waist is being fixed, to which a shoulder is being attached, same as our human body. And to this particular shoulder here at the top, we have an elbow being fixed, right? And this is the wrist, this is the wrist pitch, and this is the gripper, right? This particular portion, whatever we are seeing, is known as a gripper. That is, in this particular gripper, an object is being placed. That is, the gripper is holding the object and it is placing it some other place. Clear? That is, material handling is being done using the mechanical gripper. So this is the design. This is the design of a mechanical gripper. That is, we will be having a gripping unit, same like our fingers, and it holds the particular object and places at some other place, or it does some other activity, whatever is being required, depending upon the type of the application. Right? Next, coming to the vacuum gripper. Here we can see in vacuum gripper what is happening. Here we have vacuum caps being placed. Right? Here we are having 4 vacuum caps being placed, and based upon the movement of the manipulator, this particular vacuum cap sucks the object. For example, we have taken a box here, the medicine box. Right? We have a medicine box being placed. So this particular medicine box is being sucked with the help of the vacuum gripper, and with the help of the manipulator movement, it is being placed at some other place. That is, picking and placing or doing any sort of either applicational works or in any food industries. These particular type of the vacuum type of the grippers are being used, right? In medical industries or any sort of agriculture fields or any sort of food industries, we use this particular type of the vacuum type of the grippers, where the containers are being vacuumed. With the help of the vacuum, they are being sucked, and with the help of the movement of the manipulator, it is being placed in some other place. Here we are holding the device. The device is being holded with the help of the gripper. That is, where we have a in the human we call it as fingers. It is being holded and it is being placed at some other place. In the same way, next coming to the magnetic gripper. This is the magnetic gripper, and this is the servo gripper. Right? So here, where is this particular magnetic gripper being used? See here, this is the magnetic panel. Right? MP. This is the magnetic panel. This is the magnetic panel. So, depending upon the size of the object, depending upon the size of the product, this particular magnetic gripper will be used. That is, the magnetic panel will be used. Generally, the magnetic type of the gripper are being used in the turbine industries, steel power plants, in power plants. Right, there generally will be, or in any particular type of steel industries, there we use this particular type of the magnetic grippers. Depending upon the size of the product, the magnetic panel will be selected. For example, we have a very small cap, a steel cap to be lifted. So there a single magnetic panel is sufficient. When we need to move the boiler's cap from one place, for example, we are taking a boiler cap and we need to move that particular boiler cap from one place to the other. So there we will be using 2 or 3 magnetic panels. Depending upon the size of the product, the magnetic panels will be selected, whether it is to be 1, or whether we need to take 2 magnetic panels, or whether we need to take 3 magnetic panels. Depending upon the size, we will be selecting this particular magnetic panel. So here again, this particular magnetic panels, as we can see, are been attached to the manipulator of the robot, and with the help of the hydraulic system, or with the help of the pneumatic system, or with the help of the servo system, the manipulator will be working, and accordingly it holds the object and places wherever it's been required. Right? So this is about the magnetic gripper. So next, coming to the servo gripper. Servo gripper means what? Here we have a motor. This particular type of the gripper is being acting with the help of the motor, and the electrical current, when it is been passing to the gear starts rotating. right? The gear starts rotating. With the help of the rotation of the gears, the gripper here will be acting accordingly. That is, opening and closing of the gripper will be done with the movement of the gear, right? With the rotational movement of the gear, the movement of the end effectors will be done. The movement of the grippers will be done. And this particular rotational movement is being done with the help of the servo motor, which is being placed to the end effector. Here, when we are placing an end effector to the servo motor, the electrical current is driving the gears, and these gears will be rotating in the rotational motion and gives movement to the gripper. Clear? And gives movement to the gripper. So accordingly, the gripper will be acting. Right? Understood? So here we have 4 types of end effectors, that is mechanical, vacuum type of end effector, magnetic, and the servo motor type of the end effector. All these particular 4 grippers have various applications. One magnetic type of the gripper generally uses steel power plants or boilers or any particular steel industry, etc. And the servo motor type of the gripper generally used is been working with the help of the electrical motor, where the gear rotation will give the movement of the gripper, whereas the magnetic type of the gripper is generally used in the automobile or industries, and the vacuum type of the gripper are generally used near the healthcare or agriculture or biomedicine type of the forms. So this is about the various types of the end effectors which we are generally using in our various applications, right? Next, coming to the sensors. Here in sensors we have 2 types of sensors. One is the proximity sensor and the other is the force torque sensor. So what exactly is a sensor? What is the use of a sensor? Yes, what is the requirement of a sensor? We as a human will know at what force to hold or at what force to move an object from one place to the other. Or we know at what precision we need to hold a minute particle or any particular circuit or any particular chip we have. At what precision we need to hold that particular object, we will have an understanding. But a robot doesn't have that understanding. So for this case, we will be placing a sensor near the end effectors. Right? We will be placing a sensor near the end effectors, where this particular sensor is used to sense the object. This particular sensor is used to sense the object. It is, for example, when we consider a force or torque sensor. This particular sensor will sense at what force it needs to hold that particular object and with what torque it needs to push that particular object. That is, it will sense both the force or the torque of the object, and accordingly it will move that particular object from one place to the other. If that particular robot is not having any form of sense, then what happens? It will damage that particular product. For example, we are taking an engine cylinder and we need to move that particular engine cylinder from one place to the other. We need to place it at some other place, and the robot is holding that particular engine and is placing it some other place with some higher force. So what happens gradually? There is some damage being occurred on that particular engine. In the same way, a sensor is being used to know, it is used to sense at what force or at what torque it is moving or it is placing or it is holding that particular object and placing it some other. In the same way, a proximity sensor means what? Generally, in some electrical circuit units, we'll be having some minute circuits, or we'll be having some minute chips, or we'll be having some minute wires being placed. So there, we cannot hold, a robot cannot hold those particular chips or a robot cannot hold or place that particular circuits from one place to the other, because they are very minute and they are very precise. We cannot grip them in the robot wrist. So with the help of the sensors, we will be detecting that particular object. Right? The proximity sensor is generally used to detect the particular object and place without touching that particular object. Right? A proximity sensor is a sensor which is used to detect the object and move that particular object from one place to the other. It is not holding the particular object. It is generally this particular type of the proximity sensors have been used in the electrical circuit and electrical industries. For example, this is the figure of a proximity sensor. Right, this is the proximity sensor and this is the force or torque sensor. So here what is happening in the proximity sensor? This is the robo base and this is the robo, right? And this here we are placing the sensors, proximity sensor, right? So this is the proximity sensor which we have placed at the end effector, and this particular proximity sensor in 3 directions, that is in the Z, X and Y direction, it is sensing the device, right? This particular proximity sensor in 3 directions, in the X, Y and Z directions, it is sensing the device and it is doing its particular work without holding or touching the particular object, right? And next, coming to the force or the torque sensor. So at this particular end effector, at this particular manipulator's end, we are placing the sensor. Here we can see, right? At this particular end of the manipulator, we are placing this particular force or the torque sensor, and accordingly the work is being done. At what force? The polishing. For example, we are doing a polishing operation here. You can see a sheet here. So for this particular sheet, we are doing a polishing operation. So at what force? At what force the polishing operation should be done? If we are applying more force, there is more amount of the shear stress being occurring. Right? There is more amount of errors being occurring. There will be some flaws being occurring. So at what force? The tool has to be operated. That will be detected with the help of this particular force or torque sensor, and accordingly the grinding operation will be done. A grinding operation or welding, whatever operations have to be done will be done. So here, since we have taken the example of a polishing operation, so here we have a stone polish being placed at the end of the end effector, and accordingly with some particular force, the force operation, with some particular force it is being operated, but without applying more amount of the force and damaging the product. Okay, so this is about the types of the sensors. Next, coming to the process tools. What do we mean by process tools? As I've told you, we have various n number of applications in industry when we are taking any particular form of industry, right? When we are taking any particular form of industry, in that particular industry, we have n number of operations. One is welding, the second is spray painting, the third is grinding, fourth is drilling, etc. So we have n number of operations to be done in any particular form of industry. So based upon the type of the operation, the end effector's tool will be changing, right? Based upon the operation. For example, we have taken this particular, let us take the example of this robot. Right now, since this is the polishing tool which we have placed. Now, when we require any form of welding to be done, here we will be placing some welding tool. Right? If we want any form of drilling operation to be done, so here we will be placing some drill bit, and accordingly it will be acting. For example, we require some side of grinding operation to be done. So there we are placing some grinding wheel and the grinding operation will be done. So depending upon the type of the application, the end effector's tool will be changing. Depending upon the type of the operation, the end effector's process tool will be changing. That is, a process tool in a robot end effectors are acting as an attachment. It is an attachment which is being placed to the end effector. That is, the process tool in the robot's end effector acts as an attachment or a device which is used to perform some certain specific task. Here, that is, for welding, we are placing the welding tool. For spray painting gun, we are placing the spray painting gun tool. For the cutting tool, we will be placing another tool. In that form, we will be placing all these particular attachments to the end effectors. What do we mean by this deburring tools? Deburring tools means what? For example, we have welded two different products. Right? We have welded two different materials. So when we are welding two different materials, there are some surface roughness being created on the weldment. Right? There will be some surface roughness being created with the weldment. This weldments can be removed with the help of the grinding tool. Right? This weldments can be removed with the help of the grinding tool like this. But when we have a very small product, when we have a very small object to be done, so there we will be using a deburring tool. As I've told you, with same like this particular knob of the pen, we will be cleaning it in a very precise form. Right? We will be cleaning it in a very precise form. When we have these weldments being created, we will be cleaning it in a very precise form in this particular way. So there the precision will be more. The product's precision will be more. That is known as a deburring tool. So any particular application, wherever we require, that particular application's attachment will be placed to the end effector, and accordingly the robot will be working. Okay, so this is about the process tool. So in today's class, we have learned about what is an end effector, what is the use of an end effector, what are the various types of end effectors, how they are used, what is its design, what are the applications of these end effectors, and what do we mean by the process tools and how it is used, what is the requirement, where it is used, what are the different processing tools. All that we have studied in today's class. Thank you. Thank you for today.
Like, share and subscribe. Hit the bell icon for more updates.